Okay, so as we introduce domain and range, domain, and just to go over some vocabulary, domain is referring to all possible x values, and range is referring to all possible y values. So to introduce this new chapter, we have to think about what the difference is between set notation, interval notation, inequality notation, all three being different. But set notation is more to a specific list, and I'll go over that in a minute. So when I think of domain, okay, I'm thinking of my x values. On a graph, you scan your pencil from left to right along the x-axis, and the range being that it's the y values, you scan your pencil down and up along the y-axis, okay? So I'm going to go over several examples just to kind of get us used to it, but if I look at a graph, the reason why we use set notation is when I'm talking about a specific list of points, okay? So if you look at this graph right here, none of them are connected. The dots are individual dots. They're not connected, which is called continuous. But when it's not connected, it's called discrete, okay? A graph where dots are not connected is called a discrete graph. So that's why we use set notation in this instance, okay? So there's multiple ways to do this, but I'm just going to go over the basic. I'm going to go ahead and write these as coordinates or ordered pairs. So if I look at this dot at the farthest left, okay, this is -4, 2. Okay, then you go to this next dot right here. This is -1, 0. Then you go to the third dot, and this is 1, -1. And then the last dot is 3, -2. All I've done is I've listed the coordinates of these dots. Now I'm going to look specifically at the domain and range. So domain is referring to all of the x values, okay? So when it comes to set notation, all I'm doing is listing them. And there's two rules you have to follow. The first is make sure they're in order from least to greatest, okay? The second rule is if you see any that repeat, only list it once, even if it's showing repeating. And if we see those, then I'll bring it up again. So the domain of this set of values is I look at my x values only. So that's -4, -1, 1, and 3. So I'm going to put them in order, which they technically already are. So I have -4, comma, -1, comma, 1, and 3. These are my x values. That's my domain. The range is then looking at the y values. So my y values are your y values, of course, and I'm going to follow the same rules. I'm going to put them in order from least to greatest and list them once if they show any repeating. So looking at my list right here, I have 2, 0, -1, and -2. Well, if I write it down that way, then it's not in order from least to greatest. So the smallest value would be -2, then -1, then 0, then 2. And all I've done is I've listed my y values. Now we determine if it's a function or not. So we went over this yesterday. So the function, to be a function means that it passes the vertical line test. So if I draw a line here, it only touches once, here, once, here, once, here, once. So yes, this is a function. So taking that rules of listing your domain and range, I'm going to apply it to 4 different types of examples you could see. The first type is a mapping. Okay, so if you remember a mapping, this is just another way to write coordinates. These are my x values and these are my y values, okay? If I look at my domain, which means only my x values, I'm going to list them from least to greatest, and if there are any repeating, then I just list it once. So if I look at my list right here, -7, only once, 0, once, and 3, once. And there's my answer. There's my domain. When it comes to the range, I look at my y values. Again, we're going to go in order from least to greatest. So if I look at my first value, 1. Now 2 has 2 arrows pointing towards it, but I'm not going to list 2, 2. I'm just going to list it once. So that's what I mean by repeating. So just list it once, and there's my range. Is it a function? To determine if it's a function, I only look at my x values. -7 has 1, -0 has 1, 3 has 1, so yes, it is a function. If I look at a set of values in a table, same idea. If I look at my domain, I'm only looking at my x values, that's the left side. So I have 3, negative 2, 0, 3. Again, I want to list them in order from least to greatest. So the least is negative 2, then 0, then 3. Okay, notice I only listed 3 once, even though it shows up twice, we only list it once. Then I look at the range. On my y values here, go from least to greatest. So the least is negative 4, then 1, then 2, then 6. And then I determine if it's a function or not. If it's a function, I look at the x values only. Do you see any that are repeating on the x side? And yes, we do. We see 2 3s. Since I see 2 3s, that's repeating, which means it's not a function because it cannot repeat. Domain and range of a list of values. So for these should be swapped, but let's do domain first. Domain is your x value, so that's 3, 5, and negative 2. But we need to put them in order from least to greatest. So it's negative 2, 3, and 5. The range is your y values. And again, 6, 9, negative 3, but I want to put in order from least to greatest. So that's negative 3, 6, and then 9. This one would be a function because it does not repeat, so yes, it would be a function. Lastly is a graph. This is what we just went over up here. So the easiest thing to do would be to go ahead and just list these coordinates. So I'm going to go ahead and write them as coordinate order pairs, 1, 2, 3, 4. This is negative 5, 3. This is negative 3, negative 3. This is 0, 1. This one's 4, 2. This one's 2, negative 3. Okay, so what I've done by doing that is just make it a little easier to identify the domain and ranges if I list them first. So domain first is all your x values, negative 5, negative 3, 0, 4, 2. But least to greatest is negative 5, negative 3, 0, 2, and 4. If I go for my range, that's my y values. I have 3, negative 3, 1, 2, and negative 3. Least to greatest means negative 3. There's 2 of them, but I only list it once. Then 1, then 2, and then 3. So let's just get a few more practice problems in. So another list of ordered pairs. We're just going to identify the domain and range of these ordered pairs. So domain is your x values, which I have 0, 1, 2, 3. Just make sure that they are in order from least to greatest, so 0, 1, 2, and 3. If I'm referring to only the y values, that's your range, 8, 14, 20, and 26. Make sure it's in order from least to greatest, which they are. That will not always happen, by the way, so make sure you look carefully. If I look at a set of tables, same thing, or points on a table. Domain is just your x values, so 2, 4, 6, 8, 10. Just make sure they're in order from least to greatest, which they are. This is nice and pretty for us. The range is your y values, so that's here, 7, 8, 9, 10, 11. Again, they're in order from least to greatest, so all we have to do is write them down. And ignore my little symbols there. Number 9 is a mapping. So domain is just your x values here, 0 to 4, none of them repeating. Range is your y values. So yes, you only see 3 and 9, but 3 has 2 arrows going towards it. That means it would be 3, 3, 9. But technically we do not write any repeating, so it's just 3, 9. Last but not least is another graph. So multiple ways to do it, but I'm going to go ahead and write the coordinates of these points. So this is negative 1, 4. This is 1, 0. And this is 3, negative 4. So my domain is your x value, so that's negative 1, 1, 3. Make sure they're in order from least to greatest, which they are. My range is your y values, that's 4, 0, negative 4, but make sure they're in order from least to greatest, so that's negative 4, 0, and then 4. And there you go.